Good morning. All right, let's get started. Welcome to the session on identifying and fixing issues in code using AI-based tools. My name is Venkat Subramaniam, and I want to talk just a few minutes about AI in general, and then we'll get into the main topic of how we can use AI for helping us with code. So I want to first, let's draw a line in the air for a minute. And if you take this line, I would say this extreme here, you may call this as the perpetual pessimist, who would probably tell you this whole thing is bogus, none of this is going to work, don't pay attention to AI. The other extreme, I would say, is the eternal optimist, probably who has drunk the Kool-Aid, who tells you game over, everything's going to be done by AI. I think the reality is somewhere in the middle. And part of the reason for that is that AI is a very powerful tool, but we need to really understand what it can do and what it cannot really do reliably today. So if you think about it, I use the word AI fairly differently. I don't call AI as artificial intelligence. I call it as accelerated inference. That's what AI is really good at doing. It does a lot of inference. Well, the problem is that AI has been fed with a lot of code. But we never told AI which of those code is good quality and which is bad quality. I think most of us would actually ask you the question. Raise your hand if you think humans write bad code in general. Yeah, that's pretty much right. And I'll keep my hands up because I'm one of those people. I write terrible code. And you might say, oh my gosh, seriously? You stand up and speak in front of people and you are telling me you're writing terrible code? I'll be honest about it. I cannot write good quality code, just me. But what I found out was, when I cannot write good code, I'm extremely good in finding fault with other people's code. So I realized I can use my superpower. I can write bad code, and while I review somebody's code to improve it, they can review my code, and we can collectively improve it. But here's the problem. If we use AI to write code, what is it going to write code based on? It writes code based on what it's learned. And the problem is not that we haven't trained AI enough. It's quite the opposite. We have trained AI a lot, but we never told AI, listen, this is a bad code and that's a good code. So essentially, my theory is this, and I don't think it's really a theory, and that is, humans write bad code. AI was trained on code written by humans. Now we complain that AI is writing bad code. That's called karma. So basically, it's payback time, right? So we did this to ourselves by feeding it bad code. But on the other hand, I would argue, AI is somewhat like me. I cannot write good code, but I can find fault with other people's code really well. So what I've realized is, rather than relying on AI to write code, because it's not able to do so consistently of good quality, what if I can use AI for identifying issues in code? But let's really think about this for a minute. It's important to look at tools and ask the question, what are our strengths and what are the strengths of tools that we use? I would argue the strength we have as humans is we are very creative. We can come up with ideas. We don't have a clue where it came from. You always ask this question, right, to your colleague. How do you think of that? Well, I don't know. I just thought of it, and here's a way we can solve the problem. So we are problem solvers. That's what we do. AI is not really great in coming up with innovative ideas that's not being thought about and expressed elsewhere. If somebody has written about it, it'll tell you that eventually, after you click enough number of refresh buttons. But it cannot really come up with these new ideas for you. That's us. But AI is really good at something we are not good at. Humans really have a hard time with cognitive load. We cannot really deal with complexity. We cannot sift through complexity, look for patterns. That's just not our capability. And what if a tool can help us where we are not effective, and we can be really good at what we do as humans, and not assume we can delegate that to tools? I think that's going to be a really big win. And that's the second part I want to focus on today, is how can we deal with cognitive load, and how can we deal with things we normally are not good at. Now, one of the things we often face in our lives is that we often have to work with legacy code. And legacy code doesn't have to be code written bad and long time ago. It could be on your project. You could be looking at code written by your colleague. It could be a code written by you before that long vacation. And you're trying to really understand what this code is doing, and oftentimes we have a really hard time understanding what the problem is. Secondly, if there's an issue in a code, and you're trying to find out where the problem could be, it would be really nice if a tool can be used to quickly find maybe a few things. So here is one recommendation I have that I tend to really rely upon more, and that is use AI for ideas, not for solutions. So this is something that I try to follow quite a bit, because to me, a solution is a very tall order. If I am going to take a solution and implement in production, I got to make sure that the solution actually works. It's reliable, it's correct, it's maintainable. It is something that I want to represent my reputation of putting in production. Well, if I don't have the ability to create really reliable solutions from a tool, then it doesn't make sense for me to use the tool to create solutions. But on the other hand, ideas are extremely valuable. What do we do normally in a team? When you sit down with your team, you're asking the question, here's the problem, what are your thoughts? What are the things we can think about? How could we solve this problem? So you often want to generate a lot of ideas and then eventually want to converge towards a solution. And this is where I think AI is really good, is because AI can give us a lot of ideas from a wealth of information it can bring over to us. And when you have these different ideas, you can reject maybe 80% of them, saying, yeah, you know what, good thought, but that doesn't apply to what we're doing. That's not great. But the other 20% might be really interesting. And then among that, you may say, oh, here are 3 ideas maybe we should really focus on. So to me, AI is phenomenal for us to generate ideas rather than trying to really generate solutions from it. Now, if we're in a rush and if we don't want to do our work, we often want solutions to be given to us. But as mature professionals, that's not the way we want to work. We're not interested in rushing to a solution, but we do want a lot of ideas to be churned around before we arrive at a solution. So this is where I think AI tools can be really helpful. So we talked about the benefits and the drawbacks of using AI as well, but we can think about what are some of the things we can do with it. Now, one of the problems we often face is we often look at problems that creep in the code, and these are very common errors. But these are the common errors we may really benefit from knowing what to look for oftentimes. But I want to talk about a few examples here rather than talking theory, and look at how AI maybe can help us and see how this could be a good tool to use. So let's ask AI for some examples here to work with it. So let's start with a little example. And before I dive into this example, I changed this example quite a bit, but I'll tell you what the origin of this example really is. I can't say the name of the company here, but this is a code written by a programmer who works for a fairly large company that keeps all of our 401k plans and the profit sharing accounts and mutual funds, so you know where this is going. And this programmer had written a piece of code where, given a customer, he queries for all the accounts this customer has. And given all these accounts, he walks through, iterates through them, performs a certain operation on the accounts, and then puts them back into a collection at the end of this particular iteration. Now, I got this email from this programmer, and the email simply said this: hey, Venkat, this code worked fine until yesterday. This morning, I made exactly one change, and all hell broke loose. What am I doing wrong? That was the question. So this is a very genuine question where a programmer makes one change and things fall apart. But before we look at that code, let me express my sentiment here. I'm not a big fan of works on my machine. That's not useful. I'm a big fan of it fails on my machine. This is what I am really excited about. Because, as we all know, if you are lucky, okay, if you are very lucky, right? So if you're very lucky, the code fails on your machine, right? But on the other hand, if not, it waits, unfortunately, right, to fail in production. And it's no fun to see things fail in production. I would rather things fail on my machine. So this is where I think luck really counts. This programmer who works for this company I mentioned was extremely lucky because he makes this one change and the code failed on his machine, which is pretty rare, actually. I was surprised it actually failed on his machine. So I decided to bring that code over, but obviously I don't want to deal with users and mutual funds and so on. So I distilled it to something extremely simple for us to look at. So here we have the code in front of us. Let's take a look at it. So here is a function, strings of length 5 in uppercase. So I'm going to get strings of length 5, convert them to uppercase. So given strings, which are given as a parameter, I use the stream. In this particular case, rather than strings, this person was using the accounts that he fetched for a user, right? And a map to perform a particular operation, I'm converting the string to uppercase. That particular person was doing some financial transactions in that particular code. Then I do a filter just to get things that are of length 5. And then I do a for each to add that particular element to the collection we created right there. And then I have the result of that code being returned right there. So in this case, I've got many fruits rather than accounts. And I call that function, and I'm asking for a result. I print the result and print the size in the result. Can anyone look at this code and answer what change this programmer most likely made and what went wrong? Any guess? You can raise your hand if you think you have a clue. Not a single person. I've asked this question to maybe about 1,000 people. And up to now, there's been 2 people who have answered this question. Bingo. 3 people have answered this question so far. Good job. So he said, if you convert this to a parallel stream, that's really hard for a lot of us to identify. But even more, I want to ask you this question. How many of us have seen something like this? Given a string, result.add the string. So within the for each, we are adding something to a list. Anybody who has seen code like that at work? A few hands go up, right? Yeah, slowly, pain kind of makes it hard to lift the hand. We have seen code like this quite a bit. And I've seen thousands of programmers do that code. In fact, I used to tell people never to write code like that. And you should have seen my shock one day when I opened my own source code and I had exactly that in the code. To my defense, I did leave the window open the previous night. Who knows who came in and wrote that code, right? But the point really is, we all stumble upon and make this mistake all the time. But this can be a disaster. But why? I can't guarantee I can show this to you because problems like this are really hard to show, but we will give it a try. Let's see if the demo gods are with us today and see if that really comes through in here. So we'll give it a try, right? So let's see how this is going to pan out. So let's go over here to this code. I've just brought that code here, as you can see. So let's go ahead and say, I'm going to run this code that you see right there. And you can see it says 7. So that is the correct result. But if I go back here and change it to the stream to a parallel stream, as you suggested, right? That's the only change we made in this code, nothing else, right? We didn't modify anything at all other than that. So essentially, the minute I change that code, I like this feedback loop we have here. Everybody's phone buzzes right away. That would be a really good technology to have, right? To sense bad code and immediately send signals to everybody's phone. I don't know what technology that is, but that's awesome. So essentially, the idea here is that we are seeing this parallel stream. We are writing it down. So if I go back here, and I just go ahead and run this code right now that we just modified right there and run it, it still says 7. And you might say, gosh, what's your problem, Venkat? It seems to work. Well, I can't say the code works. All I can say is the code behaves. And it depends on how it behaves, depending on the situation. Like I said, I cannot guarantee this may fail or not, but we can just try to run this a few times in here, if you will. Aha, did you notice that? So, how's that? So once upon a time, when you run it, suddenly rather than giving you a 7, it gives you a 6. And you can look at this output and say, oops, we lost one of our fruits. Imagine your code behaving like that in production. You lost some customer data, and you get this nasty call at 2 in the night. And your family is grumpy because everybody woken up because of the phone call, and they tell you your code sucks, come to work. And you say, wait, I didn't even write that code. That code was written by the dude who quit 2 months ago. Well, that's a ticking time bomb in the code. Unless you know specifically what the problem is, you may not be able to realize what the problem is. So right there, as you can see, it was a 6 instead of a 7 when I ran it literally hundreds of times. And this is what I call as being lucky to fail on your machine, but it may not consistently happen. So these kind of problems are extremely hard to detect, and so that's kind of where we are. But now that you mentioned it, notice I'm still using a stream. I'm going to just copy that over. Just give it a try for a minute. Let's go over to ChatGPT here. I'm just pasting that. Let's go to Claude here, and I paste it. Let's go back to ChatGPT, see what it tells us right now. And in this case, it says, your Java code compiles and runs without errors, thank you. But there are a few design and performance issues worth addressing, and let's break it down. So essentially, it's trying to tell you what the issues are. The connection is a little slow here, but it is trying to point out issues in code, misuse of for with side effect. Notice how it pretty much nailed it. And it says, the problem is your for each as a side effect. That is actually the real problem. The parallel stream has an issue because of that side effect in for each. So it nailed the problem straight off the bat. The first issue it mentioned was, hey, your for each has side effect. You shouldn't be writing code like this. This is one of the tenets in functional programming, isn't it? In functional programming, we shouldn't cause any side effects in the functional pipeline. And this code violates that tenet by actually mutating a shared variable right there in the functional pipeline. In fact, the sad part about this is we could have written this code literally by not doing that, and to really not doing that either, and to simply say to list like so, and that would have been just fine. We didn't have to do the side effect. We would have made this thread safe. In fact, for the person who emailed me with the problem, that was my solution, is to say, dude, don't do this. Don't be doing side effects in for each. That was a wrong thing to do in the first place. Had you called a toList or collect.toList in an older version of Java, you would have not had to really face that problem. But the point is, we all are going to make this mistake, but it's really hard for us to know that we are making mistakes. However, when I took that code and I fed that into ChatGPT, the very first issue was that your for each has a side effect. And then it goes on to tell you that this is not an idiomatic way to use the stream or functional programming. It warns you that. The remaining things are, okay. Some of these errors, often I say, is like complaining that tea is not warm when the building is on fire. So to me, that first one is the most important thing. The others are, yeah, thank you for your ideas. This is where I like ideas, but given all these ideas, I can reject maybe half of them and investigate into the others that I feel are really worth because they may be really relevant. So similarly, if I go back to Claude, and it says logic error, filter before map. Yeah, that's where I say you need to have the sense to know whether this is useful or this is completely useless recommendation. This one is really minor, pretty useless in my opinion, because it's complaining, well, you shouldn't have done the map before the filter, but that's minor in my opinion, nothing really great. Not using the stream properly in this case, and then it tells you the side effects. So the second one here was the issue, as you can see. So if nothing else, hopefully that example convinces us why AI can be phenomenal in finding issues. But here is the funny part. I was doing a workshop on using AI, and in the workshop, I gave a problem to my attendees in my workshop, and I said, here's a problem, and I've used this problem for a while now. I haven't seen any AI tool ever to have solved this problem using functional style. And I gave them the problem, and I said, solve this problem as humans, and then solve this problem using AI, with the hope that they will say, I solved this problem as a human, but AI doesn't even come close to solving this problem. Well, one of the attendees in my session said, oh, wait, you said AI doesn't solve this problem, but here I'm using this AI tool, and it solved it. And I was like, wow, maybe this is the first day that a tool I've come across that solves a problem. And I said, do you mind if I come and take a look at the solution? I go in and take a look at the solution, and literally in the code, right in the middle of the pipeline, in the map, in the lambda passed to the map, it is going out to access a global variable and mutates it. And I looked at this person and said, did you notice in the map, it's performing mutation? That's a violation of any tenet you will follow in functional programming. How would you say it solved the problem? And the person said, gosh, I don't know functional programming. You said it cannot solve it. It spit this code, so I assumed it solved the problem. Well, this is one of the things we have to be extremely careful about. If you're using AI tools, but if you don't have a clue what you're doing, or if you're working with somebody who has no clue, but says they're going to use AI, my recommendation is don't walk away from them, run. Because it's as if they're holding on to a dynamite with the pin removed, because you don't know the blast radius after this. I was in the Netherlands a few weeks ago, and one of the project managers came to me and said, I'm going to make a statement. You tell me what your thoughts about this statement is. I said, fire away. And he said, if I don't have the fundamentals, then AI will cover my back. And I said, I'm really sorry to tell you this. If you don't have the fundamentals, AI will expose your back in public in the most humiliating way. So the point is, if you don't have a clue what you're doing, AI is not the answer for us, because we need to be able to evaluate what it is producing. And in this example, the irony is, if you ask AI to generate functional style code, it generates functional style code with side effects. You take the very damn code it creates, feed it back to AI and say, what's wrong? It tells you you shouldn't have side effect. You're like, duh, if you know this is not something you should do, why are you doing it? Well, that's unfortunately the power of the tool or the lack thereof. Because it's an accelerated inference, it looks at all the code written so far and says, gosh, I've seen code being written like this, so here you go. But it doesn't really have the ability to say, well, that was a really bad code. I shouldn't generate this, should I? But once it generates the code, you can feed that back into AI, and it will be a list of things it observes for you, so that could be useful to take a look at as well in that particular case. So essentially, that's just one example, as you can see. But I want to give you a few more examples just to illustrate this and look at the power of this. So here's my next example. So this is a pretty nasty code I've written, as you can see. I had to really put some more effort to write a bad code in this case. But when you look at this code, what I have here is a function called convert to uppercase if length 5. And as you can see, this is returning a string. It takes a string as an argument. And in this case, I say string.length is 5. then string is equal to, and we convert to uppercase. Otherwise, I set the string to null, and then I'm returning the string in this particular case. Well, when you look at this code, you could ask the question, what's wrong with this code? Now, you again, be careful to separate out ideas from solutions. When you look for errors or when you look for problems in code, your AI tool may really give you a bunch of issues in the code. That's super helpful, like I said, because when it gives you 7 ideas, that's 7 things for you to consider, for you to evaluate. However, when along with the ideas of what may be wrong, it'll also shift towards giving you suggestions for fixing it. That's when we should be super careful, because if you don't pay attention, you might be tempted to use some of the solutions only to be frowned at by your colleagues later on if you did something that shouldn't be the way to write the code. So this is where I usually am very, very careful looking at solutions provided by AI versus the ideas of, oh, here are a dozen problems. Well, thank you, that's very helpful. I can evaluate each one of them, but I will stop shy of taking the solutions it recommends to fix those problems. So in this particular example, we all know that modifying an input parameter given to a function is a terrible programming practice. Now, in Java, we often declare parameters as final. But I would say a really good way to enforce this would be at the language level. If you look at languages like Scala and Kotlin, the parameters are automatically final. You cannot mutate parameters. Well, in the case of Java, you have to take the extra effort to mark it final. But whether you do or not, it's a good practice not to do it. The second thing is I often say that null is a smell. So the more we tend to program with null, it becomes an issue to write the code and maintain it. So I would definitely avoid using null. So in this case, not only that, this was an extreme piece of code where we could have just returned the value from this function rather than actually mutating the variable within each of these places. So as a result, we could have actually eliminated the need to really do as much extra work in this particular case. But let's take a look at what the AI tools can tell us about this particular code, if you will, in this particular case. So essentially, let me just refresh this. So essentially, in this case, you can pretty much say that in this case, let's see what errors it's able to identify for us. So I'm querying that, and it can make some identifications, but it can also tell us some recommendations. Let's see, it's still thinking. Let me see what this is saying in the meantime. Unnecessary assignment to parameter. So you can see it nails it really well in the beginning to say, hey, you shouldn't be really assigning to this parameter, but you can just return from there. So that's a good observation. We don't have to mutate that. And no null check, worth considering. And so I'm a little surprised it shops shy of going any further than that. Let's take a look at what well, it's still thinking. It's not done yet. Let's see here. So let me try this one more time, see if that comes through. So essentially, syntax is correct, compiles without any errors. But let's see what it tells us. So it is giving us the details as to potential issues. And it says unnecessary overwriting of the input. Again, you're able to see that it nails the problem fairly quickly. So what I want to think about here is you are looking at a code at work. It's often not a pleasant code. Somebody has written this code, and you're trying to really reason about this code, identify what could be wrong in it. You can spend all your time reading that code, but invariably, though, we are not effective in doing so because it's an enormous amount of cognitive load, and we are not really good at dealing with such cognitive load. But what if an AI tool can really do that for us? So here is, I want to give you one more example of this. So I'm a big fan of the Wordle game. And anybody who plays Wordle here? A few of us, great. So in Wordle, you typically have a word that is guessed by the program. It's a 5-letter word. You're going to provide that word, and when you do, as a guess, If there's a direct match in terms of the letter, the response is in green. If there is a match but not in a direct position, it becomes a yellow. If there is no match at all, then it becomes a gray. So by color coding, you get to know if a letter is in a right position, if a letter isn't the word at all, or if a letter doesn't exist. And you got 6 tries to finish this game. And you give it a try, you give a second try, and so on. And if you finish in 6 tries, you have found the guess. If not, you lose the game. So I said, what if I write a program that does the logic for Wordle? So here is a code I have written. In this case, I called it a check function. It's a given word and a guess word. And as you can see, I return, first of all, a 5 letters of W. In this case, a white, in my case, represents a no match at all. And then I go through and say, if there is a direct match at the location, I want to return a G for green to say, hey, this is a direct match, you got the letter in the right position. If it is not in the right position, then, as you can see, I'm removing the letter as soon as I match it. And if it's not in the right position, I mark it yellow, Y, if it's in a non-matching position. And then I return the result back to the caller. Now, when you look at this code, your question is this code correct? What is your gut feeling? Is this code appears to be right, or do you think it's got errors in it? What's your thought? As you can see, we're still reading through the code. And the more complex the code is, the harder it gets to read through the code. And programmers, how do we tell if a code is correct? How do we tell if a code is wrong? The more imperative style a code is, the harder it is to read the code. The problem with imperative style code often is it's easier to write, but really hard to understand, hard to maintain, hard to read. But I would argue that programmers are the smartest people on earth. Because when you give them a code and ask them, is this code correct? They will never tell you it's correct or not. They will always tell you it looks good. Very carefully chosen phrase, right? It looks good. When you find it doesn't work, oh, it only looked good, but I didn't really look at it thoroughly to know if it's actually working. Well, here's the point. We can take our time to find out whether this code is right or wrong. Or how about just asking the AI tools for that? So I'm just firing that code up, just copy and paste it and say, tell me what's the issue in this code, right? So basically, in this case, we can just ask the question, what's wrong with this code? And we can make the request to find it. And in this particular case, it says non-exact match logic is flawed, which is pretty impressive in my opinion, because it's able to nail the problem in just a blink. It didn't even take any time, whereas we as humans are going to be staring at it for a while, trying to really go through and understand the logic. But whereas the very first thing it said was non-exact match logic is flawed. So it's basically telling you, hey, if the letter appears more than once, you're not counting it properly, and you're going to duplicate that, and that's a wrong result. So this is actually one of the things I often use this program for, is to train my developers on writing automated tests. And if you're writing automated tests, one of the benefits of writing automated tests is to cover edge cases that you may not otherwise think about. And even worse, when you're modifying your code, if you make a mistake in the logic, then the bugs creep in. But if you have tests for the edge cases, they can catch any problems that may happen. So essentially, in this particular case, it nails the problem right away to say, and here's the interesting part. It not only tells you what's wrong, it even tries to suggest how to fix it. Again, I would say, take this with a huge grain of salt. I decided to rewrite this entire code using functional style. Unfortunately, I couldn't find any AI tool that can generate a proper functional style code for it. It took me about 20 minutes to figure out a functional way to write the code. But once you know what the problem is, you can find different solutions for it. Doesn't mark use letters properly. So again, no input validation. Those are minor ideas, nothing really to be excited about. But I would say the first and maybe the second one are the most interesting to look at. This one is still at bay, so we'll just leave that alone. But I want to give you one last example. And that is, I mentioned about cognitive load. So if you look at some of the examples of codes I've shown you so far, I would argue most of the code I showed you so far are really terrible. It wouldn't pass my code reviews. But I said to myself, what if I take a bad code and work super extra hard to make it absolutely terrible, beyond any capability of any human to write such bad code? And one of the things we often rely upon is, when you look at a piece of code, you try to really get some grip on at least a few things. You're saying, maybe there is this variable name that'll give me a clue. Maybe they use A, B, and C, but out of mistake, they named a variable more appropriately occasionally. I can grab to it. Or maybe a function name. Function names are usually not as terrible as variable names are. So maybe I can grab onto that. So I decided to take a piece of code and strip any sign of intelligence from it. And then I said to myself, if I give this to humans and ask them to tell me what this code is doing, not what the error is, right? The code is correct, but what does this code do? Can you document and describe this code? And what if I ask AI to do it? So here is the challenge for you. This is the last question I'm going to pose to you. So here is a function. I want to bring this entire function into the view so you can see the entire function. So right there, you have the function compute, which takes an n and k, and you're setting up r, which is a double to 0, c to 0. You have a loop that is looping through right there, and then we are doing a math square root, and then eventually you can see that we are breaking off this, and here's the result. So the question to you is, if you come across this code, and the question to you is, what does this code do? Anybody can guess what this code is doing? I've shown this code to literally thousands of people around the world. Up to now, there has been 2.5 people. I say 2.5, because 2 people were able to find what the code was doing. The other person mentioned something peripherally related, but not quite what it did. So I right now have a less than 0.2% success rate on this code. Anyone is able to find out what the code is doing? What was that? Look for primes. That's almost close. Good job. Almost close. So you increase the count to 3.5 people so far. So thank you for that. Prime is correct, but a little bit more than the prime to know what it's actually doing. But that's pretty good already, right? So let's grab this code, and this is the shocker. We have difficulty finding what this code is doing. Let's see what the tools are able to do literally. So this Java code computes the sum of square root of the first k prime numbers starting from n. That's pretty shocking, isn't it? Because you're able to throw this absolutely ridiculous code, which is stripped out of any sensible information you can derive from it, and we had to struggle through the code. Most of us couldn't find it. I couldn't have found it either, to be honest with you. But occasionally somebody is there who's like, I can tell you what it's doing, but not entirely exactly what it's doing either. But it's saying this code is finding the sum of square root of the first k prime numbers starting from n. And that is ChatGPT telling us. You can try different tools, if you will. And this is saying, in this particular case, what the code is actually doing. And you can see the documentation it's creating as well. So it says this code computes the sum of the square root of the first k prime numbers starting from n. So it pretty much nails it. And then it goes on to describe the function and even create the Java doc for it, and to tell you what each of the steps are doing, and it's able to describe that for you as well. The point to me is, if you're at work and you're looking at code you didn't write, but you have to understand this code to make changes to it, imagine the power of just throwing this on the tool and saying, help me out here. Just describe what this code is doing, and that can save you hours, if not maybe days of effort in terms of moving forward. And I think this is where the real power really is. So if you ask me, in this case, what it analyzed and what it's producing, again, to be able to document the code, it's almost flawless, right, in terms of its ability to digest that code and spit it out. And my argument is exactly that. That code has enormous amount of cognitive load, but the tool doesn't get bothered by cognitive load. It's us, humans, who cannot deal with cognitive load. So my argument is, we need to really take the time to understand what we are good at, and take the time to understand what we are not good at. And to me, a great tool is the one that complements us rather than remove or substitute us. So this can be really useful because it can work alongside. We can still do what we are really effective at, and let the tool do what we really are not good at. And I am not good at, I'm sure a lot of us are not good at, dealing with code that is enormously complex, code that is hard to understand, hard to read. And so not only is this useful to find issues in the code, it's also useful to be able to explain the code as well. And typically, those are the two areas where I think most of us struggle. I don't think any one of us really has trouble writing code in general, right? We can figure out and write code. We are really good at it. We can find solutions to problems. We are really good at it. But what we are not really good at is to be able to really identify issues in code, and to be able to explain and to be able to document, and along the way, to be able to illustrate there are some flaws in this, we need to really fix it. So hopefully, that's kind of where we can benefit from these tools, because AI is a very powerful. But if we really take the time to understand where that power is, I think we can leverage the tool really well. If, on the other hand, if we get infatuated by the tool and we think that it's going to replace our jobs, maybe that job is something we don't deserve after all, because we don't understand what our real strengths and capabilities are. So when programmers ask me, hey, is AI going to take my job? Should I be worried? I say, I hope it does. Because if your job is to solve problems, you know you're in a strong place. But if your job is to simply write code that a tool can write better, I don't think that's a job you want to really be paid for, because the tools are going to replace that. But at the same time, though, if your job is to evaluate the solutions it produces to determine if this is even good code or it should be different, I think then we have a very strong position. In all honesty, I'll tell you this. I love programming. But what I don't enjoy is actually typing the code. That's the kind of the least useful part of my job. When I say programming, that's not typing the code that means to me. That's a typist's job, right? But to me, programming is to devising algorithms, devising data structures, looking at different ways to solve this problem, maybe to come up with a better way to get better performance of this code. Those are the things I enjoy, the design aspects of coding, not the typing aspect. So if I can use a tool to take my ideas and spit code, and then I can refine it, I can move forward, and to analyze it, then I think we're in a really good shape. And that's basically my opinion, is that AI is super helpful, but not in the way that we keep hearing people getting excited about, but in the ways that we can actually leverage it for our strengths and the strengths of the tool as well. Hope that was useful. Thank you.